Welcome to another GCBASIC tutorial for the PIC18FxQ35 chip family. This is part 13 using SPI, Serial Peripheral Interface, and I will be using a GLCD, graphical LCD, to represent the SPI type functions. So, like this video and subscribe to the channel, please. Part 13, using an SPI GLCD. As I said, it's just to represent how you can do SPI. It's a low-level library that you can access with ease. So I've got a PIC13 plus demonstration board, and I have hooked up to it an SPI GLCD. I've taken off the I2C one from the last tutorial, and I've hooked it in. Let's have a look at that. Here's the board, microcontroller, series of wires all going over to a GLCD that's hanging down here. I've still got all the other things like the potentiometer, LCDs, etc., but they're not going to be. You can integrate those yourself. I did write a fully integrated tutorial for this whole board, but we're not doing that. We're only talking SPI to the GLCD that's down there, and we'll come back to that. There is no reference schematic for this because this board, they didn't put SPI devices on there. Yeah, they didn't. Which is not a problem because we're going to hook it in. Because of what we're going to do is we're going to hang these 4 connections plus a bit of power and a bit of ground to this SPI device. And they are these 5 lines, and I'll come back to these: DC, CS, RTF, serial clock, and serial data out, and they're all going to be outputs. You could have an input on RC5, but we don't need that. Okay. Let me, but that's where we're going to be hanging off. That's why I've hung off all those cables. Look at that. Look, they're all down here. For those who can see, you can just work out on the right here. It says RC3, 4, 5, etc. all the way down here. I've hooked all the way into those. I've also, I'm going to go on about this. I've applied voltage to here. I am running the whole of this at 3.3. Why? Because my GLCD is a 3.3 device. So I can just put my voltage into there, and the whole of my green domain is working at the correct voltage. Fantastic. Absolutely brilliant reason to use this chip, okay? So I'm assuming that you've got your software installed. You can program this chip. You've got some LEDs, potentiometer, a switch, USB, TTL, all connected. And now you're ready to connect up this SPI device. So what is SPI? I've said this a couple of times, Serial Peripheral Interface. It's another way of connecting to send data between the microcontrollers and other peripherals, such as a GLCD, shift register, sensors, SD cards. And there's a number of lines that connect this thing because they have a clock line and a data line. You have a data out and a data in, hence it's data lines with an S, and a select line. So you could have multiple devices hanging off the same output and input to the microcontroller, but it will only talk when you raise the chip select. So you use the chip select line to choose the device you want to control. So you could have 4 or 5 different GLCDs within the constraints of the power, and you could talk to one independently of the other. You could have serial memory, and it would work the same because you'd use the chip select, and that would be the SDO and the SDI. Now, let me explain. There were some, when I first started, there were different names about this. There was a thing called MOSI, that's master out, slave in, and MISO, master in, slave out. They're no longer used. It's called serial data out, serial data in, chip select. Those are the names. And that you'll see those used. So on my prototype board, I have already touched on this. I have connected up C0 to C4 with all these connections: DC, CS, RTS, clock, and SDO. Now, let's have a look at what they look like on it. This is how they're connected into my board. I've got a chip select, a DC, a reset, serial data, and serial clock. So how does that all work? Because I've got them all connected into here. Well, it's quite important because the serial data out, or data out in GCBASIC parlance, and serial clock need to be connected to certain ports, and we've said C4 and C3. And I pulled those two apart because if you're using a PPS chip like this is, you need to match your PPS to those settings. I'm using regular digital ports, non-PPS, for the DC, which is a specific thing to this type of interface that says it's data or a command. And that's a low-level thing that the library will do for you. It sends data and commands for you. It just selects the line correctly. You have a chip select, which I guess you could do without and just pull it high, leave it high. But we give you a generic library so that you can play with it. And you must have a reset line. And with all our libraries, you have something called like hash define the device hardware SPI, because you can turn on software SPI and do the same. So you've got two options. You've got hardware SPI and software SPI. And if you comment out the hardware SPI line, like you put 2 slashes in front of it, it will just go across to the software version. So most of the libraries, say most, because I didn't write them all, support both software SPI, which is bit banging, and hardware SPI, and they're much faster. That's faster. But with the hardware SPI, this type of chip, PPS, you've got to set up the PPS. So look, setup. When things don't work, don't phone. When things don't work, it's because you've got more connections between the device and there's more trouble. We know some things, right? We know that the GLCD demonstrations work. We know that. Okay, it's therefore not likely to be the libraries or the low-level libraries, because we work through those, as in these demonstrations. So work through this checklist first. Check your connections, not once, but twice. And then write your own little program that pulses each signal line on and off. Get yourself a scope or something and see if that line is toggling on the actual GLCD like you think. Is it, you could use an LED, blink it but just pulse one line, like take the CS line, pulse that on and off. Is that doing the same on the GLCD? Pulse the next one, right the way through all 5. And if all 5 work, okay, you've got the right connection. If one of them doesn't work, go look at it. Number 3, use the software SPI first, because that takes out the complexity of PPS. Because people get confused with PPS, and if it's not set up right, it won't work. So use software SPI. And what's important about using software SPI, if you have tried using PPS and it failed, you must power cycle the microcontroller. That's not a GCBASIC thing. That's because it remembers the PPS settings. You have to turn it off to make it into a standard I/O port. And only when number 3 works should you move to the PPS hardware option. Because if 3 has worked, then 4 will work for you as well, because we know that the library is good. I'm not saying it's going to work there for every first time with yourself, but it's worth going through this simple checklist. So what we're going to do is we're going to look at this SPI GLCD connect. Look at the device. We're going to use software, bit banging. That's what it's called. I had to do some research into that myself. And then we're going to change it over to PPS. And of course, we're going to, using PPS, we're going to use a bit of what's called conditional compilation. I'll show you this to make it easier for you. So with that, let's get into the details. Okay, so I am going to start up GC Studio, GC Studio, and in the spirit of true honesty, I have reset the camera because the camera has changed position looking at this GLCD. Okay, I'm going to open up my local folder, and that is vendor boards, microchip PIC13 plus board 2010 18F, and then I've selected that folder. And in there is all our code. Let me just bring that across for us. There we go. It's open. We're in the IDE. Okay, let's go look at the camera. Whoa, there's a big device there. Okay, how big is this thing? This one is, let me just bring in my American ruler. 1.94 inches. 1.94, there you go. Look, they come with bigger devices. This is an example. Doesn't really matter what it is. SPI. Okay, Control B to or use Explorer to open up the left-hand window, and then I'm going to go into SPI. Let me zoom in for you. I've been doing other work. SPI, where's it gone? 230 SPI GLCD using an ILI 9341. That is that board. 3-volt board, 3.3 volt board. Be careful, okay? Control B, get rid of that. So, what have we got? Let's just have a look in here. We have got, ooh, oh, that was me mucking around. I better take that out. I was overclocking the chip. Okay, to be honest, okay, all right. I'll be honest with you. I was overclocking the chip to see how fast I could take it yesterday. Chip defined. Great. Option explicit. Declare your variables. Okay, let's have a look at what I've done in here. I have gone and taken a piece of PPS and I've merged it together. So in the PPS, I will do the PPS stuff, because we should do the PPS stuff, is we're going to define in the PPS our ports, okay? And it's I've done a lot more work since the last tutorial, so I've got to reselect my chip here. 46 Q35, done it. All right, my peripherals. I need 2 PPS things. I need serial data out 1, SDO. I've kept it small on purpose, I guess, but I should zoom in here really. No, I'm not going to zoom in. I'll leave it where it is. SDO, and that is on, let me just think if it's on, where is SDO? That's on RC4. I'm going to add that in. And then I want the serial clock out. That's serial clock 1, and that's on RC4, which I think I've actually, it's RC4. Is it RC3? Have I got them wrong? No, it's RC3. And then I've also got the transmit, by the way. But look, I've got that code, and this code here, RC4 equals 1B, is exactly what I've got down here. I'll be honest, right? I'm not going to paste it in because I'll only break what I'm trying to demonstrate. Okay, all right. I could paste that in, it would work, but I want to show you conditional compilation. And it says in here, inside of this routine that was called subroutine init PPS, I'm saying if the ILI 9341 underscore hardware SPI exists, set the PPS. If it doesn't exist, turn it off, which is equivalent to a hardware reset. So this sets it up, but this turns it off. And it's controlled whether this constant is defined. If def means if defined. And so if it's not defined, it will set those PPS ports to 0, which makes them standard digital. This is what we want. Right, the rest of all this is all the same until we get down to here. Include less than and greater than GLCD.h, and my type, GLC type, is this like GLC type ILI 9341. And all this is commented out, look, okay? Because we're going to use software. Then we tell it what ports we're going to use. These are the ports that you need to use. These are documented in the help, data out, serial clock, the reset, data and command, and CS. They are needed for this type of device. You might find that when you do a serial device in terms of like an EEPROM, you'll need these two. You'll also need the data in, but you'll need a chip select as well. You might not need a reset. You might not need a data command. It depends on the SPI device. Look at the library. Look at the help. The rest of this we've seen. It's do some rotate the screen, put some text on the screen, do some stuff, right? Why don't we just program it and find out what that stuff is? It's programming it. It's verifying the device. Can't quite see it. I'm not really that concerned that you can't see that because it's pretty obvious it's doing it. Now, it's working. It's doing some stuff, flipping the screen around. That's all it's doing at the moment, just to get the geometry. It's not getting the geometry right, it's just testing the geometry. And then it's got the standard stuff like draw a screen, draw some small text, big text, draw a circle, change the colors, whatever it does, right? And that is just a demonstration of capabilities. But right up the top here, it's got the date and it's got, let me just make sure, software SPI. So it's software. And the speed is okay. Not fast. It's doing a lot of stuff considering what it's doing. But let's go back to the source code. I can do it at the same time, look. And all I have to do to enable hardware SPI, which then, because of that if def statement, is also going to turn on the PPS for us. All I did was press Control /. You can delete it by hand, it's fine. Function key F5, reprogram it. Now, when it starts up, it's going to automatically turn on the PPS and then call the library internal in the low-level library to utilize the hardware SPI, and it's faster. It's a lot faster. It makes sense to use it. It's much faster. So, recap. If you're using a PPS chip, you need to set the PPS, and then you would set the data out and the serial clock line to the right ports, the same ports. And if necessary, if you're using something like a EEPROM, then you'd have serial data in as well. It would be something like EEPROM_DO. Look at the help. You'll also have control lines that are normal digital ports, non-PPS, which will help you control it. But I wanted to show you a PPS device and how you set up serial and for serial for hardware and for software. And with that, I'll go back to the PowerPoint. Okay, we're going to get rid of devices externally now. We're going to go back to the internals of this microcontroller and do pulse width modulation. So we're going to do it many, many ways to dim an LED, but they're all representative and all work. They all have their own different use cases. Very varied and very exciting. So that was part 13. Enjoy.